All right, so here we're going to be simplifying basic radicals. We got square roots, cube roots, and even at the bottom a fourth root and a fifth root. So back in Algebra 1, you should have learned how to basically reduce radicals, right? And so just like a simple example would be like, let's say you have the square root of, I don't know, how about 50, all right? And so you could have learned like the birthday cake method where you like I don't really use that method, so maybe you go like this and then however that goes down here. Or you could say, okay, 50 is 10 times 5, and 10 is 5 times 2. And so since it's a square root, anytime you have 2 of something, so I have double 5s, that means a 5 comes out. So 5 comes out, and then radical 2 stays inside. Well, this is true because what you're doing really here is this. 50 is really 25 times 2. And you can break that into the square root of 25 times the square root of 2. And so the square root of 25 is 5, right? And so that's how that works. And so it's easier to do this if you find a perfect square that goes into the number that you're dealing with, right? So you can immediately know, oh, the square root of 25 is 5. If you're doing a cube, you want to look for a perfect cube that goes into the number, so that would be best. Easier or faster. Okay. All right, so here we go. So in letter A, the square root of 49. Now, square root of 49, I don't have to break down. I know the square root of 49 is 7. So that's going to come out and be a 7. I don't even have to work it out. And then what you do with your with your x to the 8th, what you're trying to do here, when you have x to the 8th, it's x times x 8 times. How many is that? 1, 2, 3, 4, 5, 6, 7, 8. And so what you're doing is you are trying to make groups of 2. So here's 2, then here's 2 more, here's 2 more, and then finally here's 2 more. So obviously you don't want to sit there and do that every time. So what you're really doing to make it faster is this. This is a square root. So you're looking for groups of 2. How many groups of 2 go into 8? Well, or in 8. There's 4 of them. Because what you do is you say 2 goes into 8 4 times. And so x to the 4th. So it turns out that this problem right here is just a perfect square. It came out perfectly. There's nothing left inside the radical. So everything was perfect. So you would call that a perfect square. Because it has a perfect square root with no remainders on the inside of the radical. All right, so here, square root of 18. So for 18, I wouldn't use 6 and 3 because those are not perfect squares, either of them. So I'd rather use for 18, 9 times 2, because the square root of 9 is 3. So I'm going to bring out a 3, leave some space for my variables, put a 2 back inside. All right, and then I do this. 2 goes into 4 twice for A4, so twice. 2 goes into 11 5 times, so B5 comes out, but then there's 1 left over remaining, okay? And for a square root, you do not have to write the little 2 right here, but you can if you want, but it's implied. All right, over here, this already has some items outside, or in the front as coefficients basically, 2c squared. So whatever comes out, it's going to multiply with them, because remember, these are multiplied right now. So if I bring something out, it's going to multiply with the 2 and the c squared. All right, so here we go. So square root, the best thing for 75 is 25 times 3. So 5's coming out. 5 times a 2 is 10. Leave some space, put my square root back, and put a 3 there. Now, I have c squared here. 2 goes into 7 3 times. So 3 more c's are coming out. So that makes c to the 5th. And then if 2 goes into 7, there's 1 left over. All right, 64. Now, 64 is actually a perfect cube, right? Remember, 4 times 4 times 4 is 64. So that's just going to come out as 4. 3 goes into 10 3 times. So y3, leave a little space, cube root. So 1 remaining y. And here, 3 goes into 2, not at all. So x squared just stays inside. All right, for 24 over here, the best perfect cube that goes in 24 is 8. 8 times 3. So the perfect cube, the cube root of 8 is 2. So 2 is coming out to multiply with a negative 4, so it's negative 8. Leave some space, cube root, put my 3 back. And you have to write that little 3 up in the corner right there, the index, right? Oh, I thought I had that on here. Oh, that's the next one. So that little number right there is called the index, right? All right, so let's see. So now for my x's, 3 goes into 3 one time, but there's already one x out here, so that'd be x squared. And 3 goes into 7 twice with 1 remaining. All right, down here, letter F, the square root of 100 x to the 4th. So the square root of 100 is 10. I don't even need to work that out. And 2 goes into 4 twice, so there you go, another perfect square. Here, the cube root of 27. Well, 27 is 3 times 3 times 3, so 3 comes out. 3 goes into 6 twice. 3 goes into 3 one time. Oops, wrong letter. So that would be a, oh my God, a y squared and an x, right? Because 3 goes into 3 one time. And so that's a perfect cube. Okay, so now with these bigger numbers, it's a little bit harder down here to break them down. So like, 160, and also this is a fifth root. I mean, fifth roots are powers of 5 that are perfect. 1 to the 5th is 1. That's kind of not helpful. 2 to the 5th is 32. That's kind of a common one. But like 3 to the 5th, I think it's 343, but you just don't have those memorized. And so with bigger numbers and bigger roots, you're going to have to just break them down. And so I have it all broken down for us. 160 is 80 times 2, 80 is 10 times 8, or you can use 40 times 2. It doesn't matter what you start using, but as long as you break them down, and all these numbers here are just the prime factors of 160. So the only thing that makes 5 is 5 and 1, so it's a prime number, right? 2 is 2 and 1, so all these numbers here. So when you look, I have 1, 2, 3, 4, 5 2s. So all those 2s right there are going to come out. So let me make this a little smaller. So that one, that one, that one, that one, that one. So a 2 is coming out basically. So I got 2 out, leave some space, put my fifth root back, and that 5 never got touched, so put that back. And here, 5 goes into 5 one time, 5 goes into 8 one time with 3 left. So there's my answer. Over here, 162, broke it down. I'm looking for a 4th root, so I have these 4 3s, good. So 3 comes out, 3 times a 5 there is 15. Leave some space for the letters, put my 4th root back, and that 2 is just sitting there, right there. All right, 4 goes into 8 twice, no remaining. 4 goes into 5 once with 1 left. And 4 does not go into T1 at all, so that T just sits there. And that's it.